So good morning, everyone. So once again, welcome to Physics by Physics. And in this C.T.P series, we are discussing the E.M.T part. And in E.M.T, we were discussing about in electrostatics part, we were discussing the concept of dipole. So we have taken a few questions. In today's session, also we will focus on the questions related with electric dipoles. Clear? And as you know, through these questions, you can solve these questions for NET-JRF exam, IIT-JAM exam, GATE, JEST, TIFR, even in CUET. So these questions will help you. Once your concepts are clear, whether it is asked in NET or JAM or GATE, that is immaterial. Main thing is conceptual clarity of the topic. So that's why I am focusing on the concepts, so that if you get any question from different exam, you will be able to solve it. So let's see. So we were taking questions from this file is polarization, electric dipole and polarization. And so I think we have discussed, let up to 4 we have discussed. Sorry. Now see this question. Question number 5. It is given that a particle of charge, let's maximize it. See this question. A particle of charge E, it is given that particle is having charge E and mass M, is located at the midpoint of the line joining the two fixed collinear dipoles with unit charges. These charges are units, and these are the two dipole, plus minus. So one dipole is in this direction, another dipole is in this direction, and they are collinear. And the distance between charges is 2d. And these two dipoles are collinear. The particles is constrained to move only along the line joining the dipole. So particle is constrained to move along this direction only. Assuming that length of the dipole is much smaller than their separation, the natural frequency of oscillation of the particle is. So when particle is performing simple harmonic motion, what will be the frequency of oscillation of this charge? So you have to use the concept of simple harmonic motion. So what you do in simple harmonic motion, if you find force on a particle, that is, and if you slightly displace it from its equilibrium position, so that force is always opposite to the displacement. If you can express in that form, then you can find its period of oscillation. So let's see how you will find. So to see this figure, so this is question number 5. Question number 5. So in this question, you have to use the concept of simple harmonic motion. So you know that for simple harmonic motion on any particle, if force is proportional to minus x, opposite to the displacement, or if you can write force can be expressed as minus kx, where x is this very small displacement from its equilibrium position. So if you can express force in this form, then you know that this is M. We have to write the force equation. This is minus Kx, and this will be given by, this will be minus K by Mx. And if you write this in this form, then solution of X will be oscillatory solution. You have sine and cos form. So where omega is given by under root K by M. You know mass, and then you have to find this constant K. If you can find the constant K, whether it is charged particle or any other particle, you will get omega. Omega is 2 pi by T, and or this should be 2 pi F. So you can find either F or time period or omega angular frequency just by calculating K, because mass is given. Only thing is you have to find constant K. Is it clear? So that is the basic concept that we will use. That's why I have discussed it. Now see what will happen here. Consider this is the midpoint. This is one dipole and this is another dipole. Let's say this is minus, this is plus, and it is slightly displaced from its mid position. This displacement is x. This is another dipole. You have minus plus. So it's like this dipole. Dipole direction is from negative to positive. This dipole is in this direction. And this dipole moment magnitude is given as unit charge is 1 2d. So this will be the dipole moment because charge is given in as 1 unit. And it is given that this will be r, and this distance in equilibrium position, this is also r. So when you displace it, let's say at this point, you have displaced the charged particle slightly to distance x. So what will be from this dipole, center of the dipole, this distance will be r plus x. And from the center, let's see, this is with center. So this distance is r. So this distance will be r minus x. So what you have to do, what will be force experienced by this charged particle E when it is slightly displaced to this point? Charged particle is now displaced to this point. So if you want to find what will be force experienced by charged particle Q if it is slightly displaced, so you have to find electric field. So force on the charged particle is given by F is E into E. And you want to write this in terms of Kx. If you can express in terms of Kx, find out K, and then mass is given. So you will get the frequency of oscillation. So let's calculate. Try to calculate it. Try to calculate. So, and you know the what is the field due to dipole? If dipole is along z direction, you know that in this symmetry. If this is x direction, this is y direction, and this is z direction. So if dipole is placed along x direction, this is the dipole P, and at any point P, what will be electric field? Electric field is given by P by 4 pi epsilon naught r cube. This is 2 cos theta r cap plus sin theta theta cap. So let's say this will be dipole 1 and this will be dipole 2. So one point is, both points are what? Opposite to the dipole. So we are considering this type of point. So this point, at this point theta is pi. If this is the direction of dipole, so dipole is z direction. Opposite to this theta is pi. So whether if you are considering this dipole, for this also theta will be pi. For this dipole also theta will be pi. And what will be the direction of the electric field? In both case, you will see one field will be in this direction, E1, and E2 will be in this direction. Because if you put theta is equal to pi, if you put theta is equal to pi, this direction is r cap. So electric field is in the minus r cap direction. So this is the dipole symmetry. In dipole symmetry, at point P, electric field will be towards the direction of the dipole. So now the resultant field at point P is given by, we are calculating it as a E1 minus E2. Let's see, resultant field is E1 minus E2. So E1 is what? You have to put theta is equal to pi. So I am taking P by 4 pi epsilon naught. This will be, take 2 because this value is pi. So 2 pi 4 pi epsilon naught. Now we will write it as 1 by r plus x cube. And then 1 by 4 pi epsilon naught. This is r minus x whole cube. So this will be the resultant field. So let's calculate this value. So take, this will be 2p, because theta will be pi, so you will get only this term. This will be 0. So this is 4 pi epsilon naught. And if you take r cube common, this will give you, and this x is very small, minus 1 by r cube 1 minus x by r whole cube. And this x is here, this x is far, far less than r. You have a slight displacement from the equilibrium position. So you will get 2p by 4 pi epsilon naught r cube. And this will give you 1 plus x by r power minus 3 minus 1 minus x by r power minus 3. Then we will use binomial expansion because this value is x by r is far, far less than 1. So let's use the binomial expansion. So you will get 2p by 4 pi epsilon naught r cube. This is 1 plus 3x by r. And this is 1 minus 3x by r. This is 1 minus 3x by r. And then minus 1 plus 3x by r. Neglecting the higher order term. Now see what will be the electric field. just check the value. So this 1 will cancel out and this is minus 6x by r. So resultant field E is given by 2p by 4 pi epsilon naught r cube, and you will get minus 6x by r. P is 2d. So just see, this is given by 2 into 2d by 4 pi epsilon naught. This will be what? R cube. This is r power into minus 6x by r. So finally, electric field will be given by this 2, 4 will cancel out. So what you will get? Minus 6d by pi epsilon naught r power 4 into x. This will be E. So force is E into E. So that will be minus 6 dE by pi epsilon 0 r power 4 into x. And now you can write with x. So omega is given by under root k by m. Because this condition, you can see that it performs simple harmonic motion. And then k is this value. So you will get 6 ED by pi epsilon naught m r power 4. So which one is correct here? The C. Yes. Fourth option is correct. So this will be the angular frequency of oscillation. So just see, it's a question of dipole. So you must know how to find the field due to dipole. Then you have to use the concept of simple harmonic motion. Whenever you have to use concept of SHM, you have to find force on the particle, whether it is charged particle or any other particle. And if you can express in this form, then you will get the force experienced by it, express in this form and find the angular frequency omega. Clear? So must remember this concept. Now see this question. Again, it's based on dipole. Let's solve. Question number 6. Solve question number 6. So now see, in this question, you have two dipoles. Now one dipole in figure P1 and P2 are two perfect dipole. When I say perfect dipole, these are the small dipoles. And they are separated by a distance r apart. And then find the torque on P1 due to P2. So you know that whenever a dipole is placed in an external field, it will experience a torque. And that torque is given by P cross E. Torque experienced by the dipole is P cross E. So you have to find torque on 1. So this is P1 cross E2. Torque on dipole 1 due to P2. So at this point, you have to find electric field due to P2. So what will be electric field in this symmetry? Let's see if this is the direction of the dipole. This is P2. and this is the center of the dipole, and at this point, that is r distance away, what will be the electric field? So you have to use, now we have to assume this to be a z direction, because when you are applying the formula using the spherical symmetry, dipole must be in the z direction. So when it is in z direction, what will be theta? Theta is pi. What is r cap? This is r cap in spherical symmetry. If you have a sphere at any point, this will be the radially outward direction. So we are considering this point, and this is the z direction. This direction is z direction. So here you have a r cap direction. Now what will be E2? E2 is given by P2 by 4 pi epsilon naught r cube twice cos pi r cap plus sin pi r cap. This is twice cos pi r cap plus theta cap. This will be theta cap. Just like previous case, I have given the formula 2 cos theta r cap sin theta theta cap. So cos pi will be 0. This sin pi will be 0. So E2 is given by cos pi is minus 1. So this is minus 2P2 by 4 pi epsilon naught r cube. Direction is what? Direction is minus r cap. So I'm taking this direction to be E2. Because this is the r cap direction, electric field is in the minus r cap direction. So again, just see if this is the dipole direction, at this point, this is the direction of the E2. Assuming this is that direction. Now, if you place a dipole P1 here, what will be torque? P1 cross E2. Just see, magnitude will be simply you will get P1 cross E2 and direction will be inward. So torque tau 1 is given by P1 E2 and direction is inward, pointing inward using A cross B, because P cross B, cross product of two vector is pointing inward. So this magnitude is given by twice P1 P2 by 4 pi epsilon naught r cube. This is the magnitude of torque 1. So that is 2 P1 P2 by 4 pi epsilon naught r cube. So D option is correct. In this case, option D is correct. Clear? 2 P1 P2 by 4 pi epsilon r cube. Similarly, there is another question. Now you have to find torque on P2. Now you have to find torque on P2 due to P1. Let's check. Torque on P2 due to P1. So what you will do now, this is the dipole. You have to find field at P2. So in question number 7, torque on P2 is given by P2 cross E1. This is P2 cross E1. So now consider this dipole is P1. Now at this point, what will be theta? Now this is z direction. So in spherical symmetry, this will be theta pi by 2. So what will be electric field E1? This is given by P1 by 4 pi epsilon naught r cube. Again, same formula you should use, cos pi by 2 r cap plus sin pi by 2 theta cap. cos 90 will be 0. So this will give you P1 by 4 pi epsilon naught r cube, direction is theta cap. And what will be theta cap in spherical symmetry at this point? Theta cap is this direction. So electric field will be in the same direction. This is the direction of E1. Now see, this is P2 and this is placed in an external field of E1. So what will be the torque? P2 cross E1. So magnitude of torque is given by P2 E1. And what will be direction? Again P cross E1. P2 cross E1. So that is also inward. And what will be magnitude? This is P1 P2 by 4 pi epsilon naught r cube. P1 P2 by 4 pi epsilon naught r cube. So in this case, question option C is correct. Here option C is correct. So just see, you should focus how you will use write the electric field in spherical symmetry. Symmetry is important. Only then you can calculate the electric field. We have derived this formula assuming dipole is along z direction and we have written in spherical symmetry. So whatever be the direction of the dipole, if you assume that as a z direction, only then you can apply this formula. Clear? Chalo. Now we will take, let's see this question. Question number 10. Question number 10 is, let's solve question number 10. A point charge Q is situated at a large distance r from a neutral atom of atomic polarizability alpha. So this is the nucleus. There is an electron cloud surrounding it. So it's a neutral atom. And what is atomic polarizability? When you place this in external field, how you will get polarized? So it's alpha is atomic polarizability. Now you are placing a charge Q, point charge Q, that is placed r distance away. So what will happen? Now this dipole is an external field of the charge Q. As a result, this neutral atom becomes polarized. So because of the electric field of this, nucleus will shift towards right, because this is positive charge. So nucleus will shift towards right, electron cloud will shift towards left. Yes or no? So now their positive and negative charges are separated by some distance d. So this will act like a small dipole. Now this becomes a small dipole. And its dipole moment is given by alpha into E. Dipole moment is given by alpha in atomic polarizability into electric field. And electric field is given by what? 1 by 4 pi epsilon naught Q by R square R cap. This will be the dipole moment. Is it clear? And you have what you have to find here. Just see. You have to see what is the force of attraction between them. So force experienced by charge Q is what? This is the dipole moment. So force experienced by point charge Q is given by force on Q is given by Q into field due to dipole. Now you have to see if this is the dipole and this dipole is placed at r distance away, r is the distance between the charge Q, what will be the electric field at this point? So we have already calculated if this is z direction, so theta will be 0 and electric field due to dipole will be in this direction. Because when this is the direction of dipole, at this point, E due to dipole will be in this direction. In previous cases, we have seen that. So theta will be pi, not 0. Here theta will be pi. If you substitute, theta will be pi, you will get this electric field. And what will be that field? E dipole is given by, I am writing the magnitude, direction you know. So that will be given by 2p by 4 pi epsilon naught r cube. Is it clear? So what will be the magnitude? Magnitude of force is given by, just multiply these two. Force experienced by charge Q. So this is Q into P is given by this value. So I will write here 1 by 4 pi epsilon naught r cube. And let's write the dipole moment is alpha Q by 4 pi epsilon naught r square. So what will be this value? Alpha is, so here you have a 2p. So I am writing here 2p. This is 2p. P is this value. So you will write here twice alpha. Now Q by 4 pi epsilon naught, you can take it as a square. And what will be this value? This is 1 by r cube, 1 by r square. So this will be 1 by r power 5. So this is the magnitude of force. And what will be the direction of force? Because electric field is in this direction. So positive charge will move in the direction of the electric field. So there is a net attraction between charge Q and this polarized atom. So there will be a attractive force. There will be a attractive force. Is it clear? So in today's series, we focused on the concept of dipoles. Electric field due to dipole, you should calculate potential due to dipole. Dipole is placed in an external field. What will be net torque? So all those concepts we have discussed. So that's all about dipoles, and we will conclude the this lecture. In next C.T.P series, we are going to focus on the polarization only. When there is a polarized dielectric, what will be the bound charge? And how to find field due to polarized object. And we will also see what will be the Gauss law in presence of polarized dielectric. So we will talk about D vector, electric field displacement vector. So in next lecture, we will focus on the polarization. Okay. So meet you tomorrow, same time. Thank you. Thank you, everyone.